All right, today we're going to draw a map, but not for some city you've never been to. This is a map for something that's absolutely vital to any business. It's data. We're going to dive in and figure out how to track information as it moves through a system using this really cool tool called a data flow diagram.
You know that feeling, right? You're looking at a new project, maybe a new piece of software, or some internal business process, and you just feel totally overwhelmed. You're sitting there thinking, where is this information even coming from? And where in the world is it supposed to go? It's a super common feeling, kind of like being dropped in the middle of a new city without a map.
Well, the good news is there actually is a map for data. It's called a data flow diagram, or DFD for short. Now, I want you to think of it like a satellite view. It's not going to show you every single little side street and building, but what it does do, brilliantly, is give you the big picture. It shows you the main highways that data travels on, where it starts and where it winds up.
Okay, before we go any further, we have to tackle the single biggest point of confusion that trips people up with DFDs, and that is the difference between flow and structure. I promise you, getting this right from the very beginning is absolutely key.
So here's the deal. A data flow diagram is all about the journey of data, how it moves, how it gets changed and processed. Its most important symbol is the arrow, because it's all about direction and movement. A data model, on the other hand, is like the data's blueprint. It shows you how the data is organized and stored, kind of like an architect's plan for a house. It's focused on static relationships, not the actual travel.
So when you see arrows like this, I want you to think movement, action, a journey. Data is coming from point A. It's getting changed by some process, and then it's moving on to point B. That right there, that's the dynamic heart of a DFD. But here, see the difference? No arrows. This line just tells us that A and B are connected somehow. It's not saying who's doing what or where anything is going. It's just a static, structural relationship. This is the world of data modeling, completely different from data flow.
Okay, now that we've got that cleared up, let's look at what actually makes up a DFD. And the great thing is, it's super simple. There are only 4 basic building blocks. Think of this as the legend for our data map.
First up, we've got the external entity, which you'll see as a plain old rectangle. These are the sources and destinations of data that exist outside of the system we're mapping. They are the start and end points of any data journey. This could be a person, like a customer, or maybe it's another system entirely.
Next is the process, shown with a rounded rectangle or a circle. This is where all the action happens. A process is any activity that takes some data, does something to it, and spits out a new result. It's the engine that actually transforms the information.
Third, we have the data store. This is any place where data is just held. It's sitting there waiting to be used. It's not actively doing anything. It's just a resting place for information, like a database, a filing cabinet, or even a simple spreadsheet.
And finally, we have the star of the show, the data flow itself. This is our arrow. It's the path that connects everything else together, showing the actual movement of data from an entity to a process, or from a process over to a data store, and so on.
Here's a really simple but kind of brilliant way to remember the difference between those first two. An entity, like a student or a customer, that's a noun. But a process, like submit assignment or process payment, that's a verb. It's the action. This little grammar trick makes the whole thing crystal clear.
So, we have our 4 building blocks, but how do they fit together? Well, it's not just random. There's a logic to it, and it's all governed by 3 really simple rules.
These are basically the laws of data physics, and honestly, they're just common sense. First, data can't just appear out of thin air. It has to come from somewhere, like an entity or another process. Second, a process has to actually do something. It needs an input to work on, and it has to produce an output. And third, that output has to go somewhere. It can't just vanish into the void.
And this is exactly why that second rule is so important. A process that has data going in but nothing coming out, that's what we call a black hole. And a process with an output but no input, that's a miracle. Data just magically appears. Both of these are big red flags that tell you your map has a broken, incomplete flow.
This is what you're aiming for. A nice, clean, logical flow. Data comes in, the process does its job and transforms it, and new data flows out. It's simple, it's complete, and it tells a coherent story about what's actually happening to the information.
All right, that's enough theory. Let's make this real. We're going to quickly map out a simple, totally relatable example.
a learning management system, or an LMS.
So first things first, who's interacting with our system from the outside? In this case, we've got three key entities: the faculty, who provides the course materials, the student, who uses them, and an admin, who helps manage the whole thing.
Okay, let's trace the main journey here. A faculty member shares materials into the LMS. The system then delivers those materials out to the student. After some studying, the student submits an assignment back into the LMS, which in turn provides grades. And all the while, an admin is coordinating courses. Now, this simple map is where the magic happens. It immediately makes us ask important questions, like where are those submitted assignments stored? What process actually handles the grading? What happens if a submission fails? Suddenly, we're not just looking at a list of steps, we're seeing the whole system, and we can start to identify potential bottlenecks, weak spots, and areas we could improve. That is a DFD in action.
So yeah, we can draw some boxes and arrows. Big deal, right? But why is this such a powerful tool? Let's wrap things up by really focusing on the real-world value of making these kinds of data maps.
This quote from the source material really just says it all. The simple act of creating the model, of just documenting the process, is what makes the hard analysis possible. It forces you to be clear. Once you have the map, navigating the territory becomes so much easier. So here's the big takeaway. DFDs give you incredible clarity by providing that big picture view we talked about. They are an amazing communication tool because they create a common language that both the business folks and the tech folks can actually understand. And most importantly, like we saw with our LMS example, they make complex analysis manageable. They help you see exactly where you need to focus your attention to solve a problem or make a process better.
So, I'll leave you with this question to think about. What's the first process in your own work that you could map out? It doesn't have to be perfect. Just try drawing a few boxes and arrows. You might be totally surprised by the new perspective you gain. Thanks for tuning in.